Immunoglobulin M and immunoglobulin A can form polymers. Although all immunoglobulin molecules are constructed from a basic unit of 2 heavy and 2 light chains, both immunoglobulin M and immunoglobulin A can form multimers. Immunoglobulin M and immunoglobulin A C regions contain a tailpiece of 18 amino acids that contains a cysteine residue essential for polymerization. An additional separate 15 kDa polypeptide chain called the J chain promotes polymerization by linking to the cysteines of the tailpiece, which is found only in the secreted forms of the mu and alpha chains. In the case of immunoglobulin A, polymerization is required for transport through epithelia. Immunoglobulin molecules are found as pentamers and occasionally hexamers in plasma, whereas immunoglobulin A in mucous secretions, but not in plasma, is mainly found as a dimer. The polymerization of immunoglobulin molecules is thought to be important in the binding of antibody to repetitive epitopes. The dissociation rate of an individual epitope from an individual antibody binding site influences the strength of the binding or affinity of that site. The lower the dissociation rate, the higher the affinity. An antibody molecule has 2 or more identical antigen binding sites, and if it attaches to 2 or more repeating epitopes on a single target antigen, it will only dissociate when all sites dissociate. The dissociation rate of the whole antibody from the whole antigen will therefore be much slower than the rate for the individual binding sites, giving a greater effective total binding strength or avidity. This consideration is particularly relevant for a pentameric immunoglobulin M, which has 10 antigen binding sites. Immunoglobulin M antibodies frequently recognize repetitive epitopes such as those expressed by bacterial cell wall polysaccharides. But the binding of individual sites is often of low affinity because immunoglobulin M is made early in immune responses, before somatic hypermutation and affinity maturation. Multi-site binding makes up for this, dramatically improving the overall functional binding strength. And that's immunoglobulin M and immunoglobulin A can form polymers. Have a great day.